Morning to everyone. Myself, Dr. S. Indrani, Department of Electronics and Instrumentation Engineering, SRM Institute of Science and Technology. Today I am going to take introduction to the course on industrial instrumentation. Under the instrumentation, explain about the pressure measurement. Pressure is the force exerted per unit area. Pressure is action of force against another force. Pressure is a force applied to or distributed over a surface. The pressure P of a force F distributed over a area A is defined as E is equal to FIA. The pressure measurement is one of the most important measurement in the continuous process industries. Pressure measurement terms, different type of pressure, absolute pressure. Absolute pressure means measured above the total vacuum or zero absolute pressure. Zero absolute represents a total lack of the pressure. Next one is atmospheric pressure. The pressure exerted by the earth atmosphere. Atmospheric pressure at the sea level is 14.6 GSA. The value of the atmospheric pressure decreases with increasing the altitude. Next one is a barometric pressure, same as atmospheric pressure. Next one is a gauge pressure. The pressure above the atmospheric pressure represents a positive difference between the pressure measured, the pressure, and existing atmospheric pressure. Can be converted into absolute by adding the actual atmospheric pressure a value. Next one is a differential pressure. The difference in magnitude between the sum pressure value and some reference pressure. It is, in a sense, absolute pressure would be considered as a differential pressure with a total vacuum or zero absolute as the reference. Likewise, gauge pressures would be considered as a differential pressure with atmospheric pressure as the reference. This is the various pressure. This is example for the pressure measuring instruments. Types of pressure measurements: gauge pressure, vacuum, compound, absolute gauge. Next one is a differential pressure gauge, differential switch, vacuum, absolute gauge, differential pressure switch, differential transmitters, differential pressure transmitters. Pressure gauge. Pressure gauge is used for measuring the pressure of a gas or liquid. Vacuum gauge is used to measure the pressure in a vacuum. A compound gauge is used for measuring both vacuum and pressure. Pressure gauge are used for indication only. Pressure gauge used for measuring the pressure of a gas or liquid. Next one is a need for the pressure measurement. Across various industries, measuring the pressure of the substance is an important part of the manufacturing process. Obtaining the accurate and meaningful data is important. It's determining the quality and consistency of the product. For this reason, accurate sensors are absolutely critical in obtaining this information. Each sensor takes a physical pressure of the element and transfers into electrical energy some kind that can be measured. There are different types of sensor to choose from, each with their own strength and limitation. Next one is a manometer. Pressure measuring device using liquid columns in vertical or inclined tubes are called manometers. One of the most common is the water-filled U-tip manometer is to measure the pressure difference in the pitot or orifice located in the airflow in air in handling or ventilation system. Constructions of the U-tip manometer: a transparent U-shaped glass tubes partially filled with a liquid, example water or mercury. One end may be open and to the atmosphere and other is connected to the pressure source. Working principle of the U-tip manometer works based on the principle of the hydrostatic equilibrium. The difference in the height of the liquid columns in the two arms indicates the pressure difference. Types of measurement: gauge pressure, one end open to the atmosphere; differential pressure, both ends connected to the different pressure sources; absolute pressure, one end sealed and under vacuum. This is a U-tip manometer image. In this figure below, they illustrate the water level in the U-tip where the left tube is connected to the point with a higher pressure than the right tube. Example, the left tube may be connected to the pressurized air duct when the right tube is open to the ambient air. Next one is the elastic pressure instruments. One of the pressure measuring is a piezo-resistive strain gauges. Piezo-resistive strain gauges are among the most common type of pressure sensor. They are used they uses changes in the electrical resistance for a material and scratch to the measure of the pressure. Piezo-resistive strain gauges are a semiconductor material which changes in the resistance when the material scratched or compressed. Next one is a diagram for that strain gauges. Pressure on the diaphragm will stretch the wires and changes in the resistance. The change in resistance in the sensor is usually measured using a Wheatstone bridge circuit. Excitation voltage needs provide the Next one is high vacuum measurement, McLeod gauge. McLeod gauge amplifies the low pressure and was developed to extend the range of vacuum measurement significantly. The McLeod gauge pressure, the vacuum pressure in the range between 10 power minus 1 to 10 power minus 5 torr. This can be used to primary standard device for calibrating other low pressure gauges. 1 torr is exactly 101325760 Pascal. That is approximately 133.32 Pa. This is a McLeod gauge image. McLeod gauge consists of a reservoir containing mercury. A blunker is attached on the top of the reservoir, which is used to rise at the lower level of mercury into the reference column and bulb. Above the reservoir, there is a bulb and the reference column. The point of connection of the bulb and reference column is the opening or cutoff point. The other end of the reference column is open to vacuum pressure and it has a reference capillary. The reference capillary has a zero reference point up to which the mercury is raised. The mercury rises in the capillary as much as it rises in the column, but only the volume differs. The difference column is attached to the measuring capillary, which is sealed chamber, and the final volume of the gas read. The volume of the gas remaining in the measuring capillary is given by Vc is equal to ACH, where H is the difference in the height of the mercury in the reference and the measuring capillary. AC is the area of the cross section of the measuring capillary, that rho is equal to ACH square by V. The next one is the Brownie gauge. Brownie gauge are a group of indirect measuring pressure gauges which measure the thermal conductivity of the gas sample. This is the image temperature measuring image for that Brownie gauge. The Brownie wire filament is typically operated in a balanced Wheatstone bridge circuit, which one of the leg of the bridge in the Brownie filament and the other three elements of the bridge circuit balance and temperature compensate the circuits. The filament wire is maintained at a constant temperature. When the gas density changes, thereby the thermal conductivity changes. The energy required to maintain the wire changes accordingly. Consequently, the voltage supplied to the Wheatstone bridge becomes vacuum pressure dependent and the measured bridge voltage can be converted into a pressure value. The Prani